Welcome to channel Maths Magic. Today we are going to discuss one of the important questions based on geometric sequences. Question is there on the screen. It says a nest of ants initially contains 500 individuals. The population is increasing by 12% each week. How many ants will there be after 10 weeks, 20 weeks? The first part. And then it says use technology to find how many weeks it will take for the ant population to reach 2000. So we'll do one by one. So first of all, you have to see over here how it is geometric question. So our population is 500 initially. So let's write it's 500. Now next week is going to be 12% more. If you can recall, increment by 12%, we can write it like this: 1 plus 12 by 100, or simply you can say that it's 500, so 112 upon 100, or 1.12. 500 1.12. So next week population is going to be 500 times 1.12. Now next week again the population will increase from 500 1.12 to 501.12 times 1.12 again, because it's increasing next week again by 12%. So every time you have to multiply 1.12% for the next week. So you can see that it's increase of constant multiplication. Like every time we have to multiply 1.12 to get the new population. So you can say that the initial population is U1 first term, and the common ratio of this increment is 1.12. Now we have to find in part A, first part. So how many ants will there be after 10 weeks? So in 10 weeks, that means we are looking for n is equal to 10. How many ants will there be after 10 weeks, right? So we have first term over here. You have to understand this very carefully. We have first term 500, which is at the beginning of week, and so this is at the beginning of week 0 week, and at the end of first week, or you can say after first week, population is this. So U2 is basically after first week, U3 is after second week, U3 is after second week. So if you are looking for after 10 weeks, that means your n should be one more than this. So n is 11 over here. Okay, now let's find the population after 10 weeks. So it is actually U11, and you remember the formula I told you? Formula was UN is equal to U1 R to the power n minus 1. This was the formula. Hope you can recall this. So it's a U11 is equal to U1 500 times 1.12 to the power n minus 1. It's 11 minus 1. Now you can solve this to find the population after 10 weeks. Okay, so let's use calculator, or if you can do it manually, you can try that, and you have to solve this to find the answer. So it's 1.12 to the power 10. So let's use calculator. So it's to the power 10 and then times 500. So it's approximately 1552.9241, so on. So we can estimate this population roughly as it's 1552.941. So we can roughly say that this population is 1550. We have just roughly estimated it. Hope it's clear. I will explain this part again. First of all, you have to understand how you can construct geometric sequence out of this. So you have to keep in mind that if any increment is happening with constant percentage change, then that sequence which you will obtain is geometric sequence. Initially you was having 500 of the population. Now next week it will increase by 12%, so we'll get certain population, and again next week the population which was there on the first at the end of first week will increase by 12%. So every time our population is increasing by 12%, that means this increment of 12% is the ratio of the geometric sequence. And second thing which I told you, that you have to be very careful of this term of the sequence. So initially it was 500, that means your u1 was 500, and this population is not at the end of first week, it's initially. At the end of first week your population is this much, so u2 is representing population at the end of second week, sorry, at the end of first week. Usually students get confused with this. They treat this initial population u1 as the result of population at the end of first week, but be careful, this 500 is not the population at the end of first week, but the population at the end of first week is 500 times 1.12, as I told you how we get 1.12. Hope this is clear. And then as I told you that it's at the end of second week is going to be u3 and so on. So at the end of third week or after 10 weeks it's going to be 11. So our number of terms for this geometric sequence is going to be 11. And similarly for part 2 your n is going to be 21. You can try this part yourself and I'll give you the answer for this part, and approximately answer for second part is going to be 4820. If you are not getting this answer, you can contact me, I'll get back to you for sure. Now part B of this question. So we have already identified u1 and the common ratio. Now we will use these information for part B. In part B it says how many weeks it will take for the end of population to reach 2000. So we have to set the equation how many weeks it will take to reach the population 2000. So we don't know that what should be the number of terms, so it's un is equal to 2000 right now, and u1 as you know is 500, and common ratio we already figure out it's 1.12. so how can we set this equation? It's un is equal to u1 r to the power n minus 1 and un. So un is 2000 and then u1 is 500, then r is 1.12 to the power n minus 1. Okay, so we can simplify this. It's 4, so we got 1.12 to the power n minus 1 is equal to 4. Okay, you know that this n which you will get over here is actually giving you the number of term, not the week. So whatever the n you will get, you have to reduce 1 to get the exact week, because I told you in previous question that when it was 10 weeks the number of term was 11. So over here when you will get some value of n, that value of n will give you number of term, not the weeks. So you have to reduce 1 to get number of week. Now the question is, how can you solve this question? In some cases we can directly use the calculator to solve it, or we can use log to solve it. So we can taking ln on both the side. So you know that if you're taking ln on both the side, it becomes ln 1.12 to the power n minus 1 is equal to ln 4, and then okay, let me clear this and then I'll write rest of this part. So this becomes n minus 1 ln 1.12 is equal to ln 4, and then n minus 1 is equal to ln 4 divided by ln 1.12, and n is equal to ln 4 divided by ln 1.12 plus 1, and then you have to, this is your, if you solve this you will get number of terms, and then you have to subtract 1 to this to find the final answer. So I'll just directly subtract 1 over here, so this 1 and 1 gets cancelled out. So now when you solve ln 4 and ln 1.12, this will give you the number of weeks it will take to reach the population 2000. So once you will solve this, your answer is going to be approximately 12.2 weeks. 12.2 weeks. Hope it's clear. Okay, over here we have used log. If you don't know about log, I'll make separate video for that. And if you want to know about log, let me know about this and comment in video so that I can get back to you for sure. Hope this question is clear. If still you have any doubts, I can help you for sure. Thank you for watching this video. Stay connected.